Yeah, hi. My name is Felix Geisendorfer, and I'd like to talk about Node.js as a networking tool. Since most of you probably don't know me, here's a little bit about myself. I joined the Node mailing list in June 26, 2009. I did that because I'm also the co-founder of a project called Transloaded, and we needed to do a lot with child process execution. We were using PHP, and if you ever tried to do command line stuff with PHP, it's not a very natural environment. And I found Node, which had very good facilities for that kind of stuff, and that's why I joined. When I joined, there were about 24 people on the mailing list, which in this room can be rounded to roughly 23. And my first patch to Node came a little bit later, in September 2009, because obviously Node was still very young, and so a lot of stuff had to be fixed. So I've been regularly contributing to Node ever since, and besides working on Node itself, I've also authored non-blocking Mysql driver for Node.js, which is written in pure JavaScript, no bindings to libmysql or anything. So that's a good example of how you can use Node for serious networking stuff. And another thing, library I released is called Node Formidable, and that's a library that can parse file uploads and do so very quickly. Well, now I've said a little bit about myself, and whoa, this is going too fast. Okay, and I'd like to ask a little bit about you, so I have the right context, so I know where I need to go into detail and where not. Who in this room has used Node.js before? Raise your hands. Oh, that's a lot of people, good. That means they can assume a little bit of knowledge, but I'll still get into details for those who have not. Who's using JavaScript in their daily programming or on a regular basis? Most people, awesome. Now, this is where the big divide will come in. How many of you are on port 80? Like you produce software that mostly responds to port 80? That's most of you, that's what I thought, because you're already doing JavaScript in Node. But that's not what this talk is about, because how many of you are outside of port 80 on a daily basis? Wow, that's a lot as well. You guys are good hackers, not focused on just one thing. So that's what most of this talk will be. What can you do with Node that's not HTTP? I can go over this quickly, since most of you have heard about Node before. Node's goal is to provide an easy way to build scalable network programs. Of course, easy and scalable in the same sentence should be a warning sign. What it really means, it makes certain problems that come at scale and that are hard easy, while also making some problems that were previously easy a little bit harder. That's what you get from the callbacks, for those who already know. Node was created by Ryan Dahl in early 2009. It's using Google's V8 JavaScript engine. That means there's no DOM, which a lot of you probably work with, just pure JavaScript. And on top of that, it basically gives JavaScript a module system, I/O bindings, and parsers for common protocols like HTTP and stuff. Let's look at Hello World in Node, and this is the network edition of Hello World. So instead of just printing something to standard output, what we're doing here is we're requiring the net library, and then that does TCP and Unix domain sockets. And we tell the net library to create a new TCP server, which gets a callback with a parameter socket, and this function is always called when there's a new connection coming in. And then on the last line, you can see we're listening to port 0x27C3 in hex for this event's purpose. And then we're receiving connections. When we receive a connection, we write hello world with a new line, and we end the socket. So when we execute this program running node hello.js, we see that the first program is started in the background, and then we can execute another tool, which is netcat, that connects to localhost. For those not familiar with netcat, it's telnet, but a lot, with a much better interface. And so what it does, it connects, gets a hello world message, and then exits. So that's how you write hello world as network code in Node. For the purpose of this talk, I also tried to port this script to C, and anybody who's done that before can probably attest that it's not easy. I worked through all the man pages, and this code would turn out to be, I don't know, around 200 lines of code to get all the non-blocking I/O facilities, select, and everything working. So it's kind of nice for those of you who have done C hacking in the past to see that this can be done relatively simply. Since most people of you use JavaScript, I won't go into the details too much about JavaScript. Or actually, let's raise hand. Who thinks JavaScript is a stupid idea to write serious applications? Okay, there's a few skeptics. That's good. That's good. Well, I'll not go into too many details, but let's look at 3 reasons why Node is not using Python, Ruby, or Java, or Lua, or some other language, which certainly could be done as well. First of all, JavaScript has good parts. A lot of people don't know that since it's the world's most misunderstood language, but JavaScript has closures, it has JSON, and it's a very flexible language that you can twist in all kinds of ways. And if you're interested about its good parts, I recommend the book on the right, which is JavaScript: The Good Parts by Douglas Crockford. And if you want to know about all the bad parts as well, there's a definite guide, which, which is slightly bigger. And it will, basically, I think it also includes the DOM, and the DOM is the worst part that most people know when they think about JavaScript. Reason number 2 is there's a war on JavaScript engines going on that's much better than the war on terror. And this war is currently fought between 5 major contenders. There is V8, which is produced by Google for Google Chrome. There's SpiderMonkey, produced by Mozilla for Firefox. They're actually getting really fast these days. Brendan Eich is working very hard to make some a top-notch engine. I think their latest optimizations are called TraceMonkey and JagerMonkey. Then we have JavaScript Core, which is Safari, Chakra IE9, and something else from Opera, which hasn't shipped. That's kind of why I put those 2 on bottom. And well, the good thing about those wars is JavaScript is getting one of the fastest scripting languages on this planet. So there's a lot of resources, a lot of smart people working on the problem, and that makes JavaScript an excellent choice for writing scalable servers. And last but not least, JavaScript itself has no notion of I/O. It has no notion of threads. It's single-threaded. It has no I/O facilities in the standard library. And that's what really made Ryan Dahl pick JavaScript instead of something like Lua, because all those other languages have blocking calls as part of their standard library. And so people who will see those blocking calls will prefer them, and they'll write libraries that are not compatible with non-blocking code. Let's look at non-blocking code itself. In a traditional stack, you execute queries by saying select query A, and then this line would work. It would send something to a server, wait for it to return, then it gets results, and then query A done would print. And same goes for the second query. So this is all fine and nice. That's what we're all used to. But the problem, of course, is that the time it takes to execute those 2 queries is the sum of both queries. You have to wait for the first one, and then you have to wait for the second one. And that's really a problem because disk or network access is 1,000 to 1 million times slower than accessing your CPU or memory. And so that's why you kind of want to parallelize things when the technology on the other end is also parallelized, which any database worth using should be. So what Node does is changes this concept of doing something to first specifying what you want to have done and then providing a callback. And of course, what happens is this db.query line executes right away, and then the second query line executes right away. Both of these queries are processed in the background, and then when they are done, the callback comes back with the results. And this essentially changes the time required to execute those queries to the maximum time it takes to execute one of those. And that's a big win for applications that do a lot of access to a database. How is this done? This would be a talk of itself, but it's done with a library called libf by Mark Lehman. It's basically one big infinite loop called the event loop. It polls the operating system for events. The operating system has non-blocking facilities that are more or less good to do that. Its details are very complicated, but basically what this library allows you to do is it allows you to tell the operating system to do something, then register watchers and callbacks, and then whenever what you wanted to have done is done, libf calls you back. And it basically shifts all the stuff you would normally do with threading to the operating system where it belongs, because that's hopefully one of the most optimized parts of your stack. Buffers. Of course, JavaScript has no notion of binary data, so you need some sort of way to represent this data. So Node has come up with an abstraction called buffers, which are objects that represent a raw C memory allocation. They are similar to an array of integers, and they can be converted to and from JavaScript strings. So if you have strings, you can turn them into buffers and vice versa. The API for that, here's a few functions that are worth looking at. We have buffer.write_hello buffer. This would write data into a buffer from a string, turn it into bytes. Of course, your buffer needs to have the right size beforehand. Buffers don't automatically resize, they're really low level. You can do the reverse and take now this array of bytes and convert it back to UTF-8. Node also has a nice little stream libraries that can take a stream of UTF-8 data and make sure you don't cut off the boundaries for those who care about those details. Then you can access each byte on the buffer as an index, like in an array, and assign an integer to it. And then you can call buffer.slice, which gives you a new buffer, but this buffer covers only a range of the previous buffer, but still points at the same memory. So if you manipulate this buffer, the underlying parent buffer will also be manipulated. How does this look? Let's have a look at reverse hello world and see how buffers usually come to you in Node.js. Again, we have the net library, create a server, listen on the port, and then we ask our socket to give us a data event whenever data is coming in. We have a callback with a buffer. And if we log this buffer to the console, we can see at the bottom of the example that if we pipe hello world into the netcat tool, which basically sends this string to our little TCP server, then we see the buffer printed out. And Node is already nice to us geeks and converts it all into hexadecimal. You can kind of see hello, 20 is a space, and then world, and C-array is a carriage return. And that's usually how you can get buffers. By default, Node will always give you buffers on everything you do, but you can also set an encoding on a socket if, for example, you're dealing with UTF-8 or ASCII data. Pretty simple. Streams. Streams are probably the most important concept in Node because what arrays, or let's look at this quote from Chet Schmidt, who's a very smart fellow. He said at JSConf EU, streams are to time as arrays are to space. That basically means while you access an array in terms of spatial indexes, where you say item 0, 1, 2, 3, you access a stream over time. That means the stream provides data to you at certain time intervals, and then you have this piece of data in time at one point. You can choose to now push it into an array or something, but it essentially flies by you. So the time is what gives a stream its index. In Node, streams are also wrapped into a nice little class, and this class is called streams. You can say stream write, and you can pass it a buffer. The buffer can contain any hexadecimal byte representations as in here. You can pump in a string, whatever you have. You can also pause and resume streams, which is very useful. Imagine you have a file upload coming in, and this file upload is coming in really fast, but your disk is really slow right now. What you need to do is you need to pause this file upload until your hard disk has caught up, and then once you can receive data again, you do that. Otherwise, you would build up memory in a scenario like that. And of course, you can also destroy the stream, which, depending on what kind of stream it is, will terminate the underlying connection. Then on the other end, streams are emitting events, and here are the three most important events. Let's start with the middle one, data. Data is what you always get when there's data coming in on the underlying socket of the stream, and you get an event which is a buffer. Of course, depending on your protocol, there's no guarantee that this will be a full package. If you're using TCP/IP, it doesn't give you those guarantees that everything you send off at once will come in at once. So you might need to take care of concatenating stuff together at this point. But that's the true nature of a stream, so that's why Node doesn't try to abstract it away from you. Then you have the end event, which basically means connection was closed on the other end. Now you can decide to clean up some resources or do whatever. And then you have the train event. And the train event is kind of important because In the previous slide, we saw writing to a stream. But what happens if you write to a stream so fast that the other end can't receive it at the same speed? Well, essentially, you build up a queue, and the more you build up of that, the less memory your operating system has. So to avoid this effect causing problems for your system, you can basically write data to a socket or to a stream, and then wait for this train event, which will tell you the socket is now flushed, everything has been sent to the other end, and if you write data again now, I'll start buffering again, but basically you're not building up memory right now. Let's look at a nice little example of another stream function called pipe. What we're doing here is we're creating, again, a TCP server, and this time we're saying that we want the data from the socket piped back to the socket. So that's essentially an echo server that just mirrors back everything you sent into it. What's nice about this is it fits really fits into a tweet. It's, I don't know, 103 characters. And what's also nice is it doesn't care what type of socket it is. For the simplicity of this example, we're using the same socket and creating this loop effect. But you could take a file system stream that streams some data from the disk and just stream it into a socket, just like you're used to from Unix pipes. And that's a very powerful concept, and I think also something that Node will try to get even better facilities for in the future. If we execute the server, of course, we start the echo script in the background, and then when we netcat into it and write, "Hi, how are you?" then that's exactly what we get back. Pretty straightforward. Pcap module. Now, if you really want to do some fun stuff in a network, sometimes you need to understand what another network application is doing, possibly in applications that you don't have the source code to or otherwise are unsure what protocols it's using. And so libpcap is a library provided by, I think, most Nix operating systems that allows you to put an interface into a promiscuous mode and then listen for packets that come by. And Node.js itself doesn't have a binding for that, but somebody has written a very nice binding, and it's called Node Pcap, and you can install it using the Node package manager, running npm install pcap. And what you get from it is basically a scriptable TCP dump program. That means every packet that arrives on the network triggers an event, and you can now decide to either just log this data, filter it, or you can react on it. If maybe you want to do something that, let's say, is timed to a certain event in the network, you want to trigger another event in that network, that's something you can do very easily with this binding. I have a little example here doing just that. What this example does, it includes utility library that's just for printing to standard output. The Pcap module, which is the binding we're talking about, then it declares the filter that we are interested in. We are interested in TCP port 0 times 27C3 here, and then we're creating a new session. And we create the session on LO0, which is our loopback interface, or local host, and we pass this filter in. Just couldn't fit it on one line, so it's up there. And so depending on what you want to do with this now, you get, from your sessions, you get packets. By default, I think those packets are just raw buffers, byte representations of the packets that were sniffed. And what you can do is you can decode this packet, and that will basically put it into human-readable data structure. It will tell you the destination, the source of the packet, and all kinds of other network-associated details. And what we're doing in this example is we're telling the Pcap library to print a nice human-readable summary of the packets that we received. And then we're checking if the packet contains any data, and if it contains any data, we print this data. Which is what we're doing in this example here. We are running our own old hello.js script, put it in the background. We run pcap and put it in the background, and then we use netcat to connect it to our hello.js server. And as we can see here, that's the packets that are sent. There's also a TCP acknowledgement going on. And then what we can see at the bottom, there is a egg push package, which says hello world. And so that's basically the package that we sniffed that was coming from our server back to the client. And of course, there's a lot more details to what you can do with this, but it should give you an idea that this allows for a rather interesting way to script network debugging or whatever you do. I actually used Pcap for writing my Mysql driver, since they have documentation for their protocol, but let's say there's certain gems in there that they don't really document. So you have to get creative. So to recap, Node basically has all the facilities that you need to do networking. There's binary data handling via buffers. There's I/O abstractions, which are streams. And then there's package sniffing via Node Pcap. So that's essentially the basic toolkit that you need to do to have fun in a network. If anything's missing, please let me know in the question. But I think those are the essential concepts that you need to be familiar with to use Node. Node, of course, can also do a lot of other stuff. So it won't fit in 30 minutes here. But Node has very excellent support for HTTP. Ryan has written an insane handcrafted HTTP parser in C, which I think allocates only 40, 50 bytes per connection, probably optimized beyond what you actually need because the overhead in your application layer will be so much higher. There's what I mentioned in the beginning, very excellent child process facilities. That means you can spawn a command line utility as a child process and then get events on standard out, on standard error. You can stream data into standard in. All of these are streams, as we've just seen previously. Of course, you can also do Unix domain sockets. That's done with the same net library. There's a DNS module included for DNS queries. All of that is non-blocking. There's UTP support and cryptography and a bunch of other things I forgot to mention. And if all of that is not enough for you, there's a really fast-growing ecosystem of libraries out there. Most of them can be found in the Node Package Manager repository. And there, I don't know, there's somewhere between a few hundred up to maybe 1,000 tops of libraries that you can use at this point. Speed. Let's look at what makes Node so interesting and why it's received so much attention. It's basically was created because Ryan was working with Ruby before. He came to create Node.js, and at some point he was writing Ruby web servers like Mongrel, comparable to that, and he tried to make it faster, faster, and faster, and then he realized, well, Ruby is really the bottleneck, I can't go any faster anymore. And that's when he looked into using another language. For this benchmark was actually done by Ryan himself. Since benchmarks are very difficult to do, and you can take a lot of flame for not doing them properly, I'm using somebody else's. And what he's doing here is he's creating an HTTP server, and creates a 1 megabyte buffer. And then he basically, for every HTTP client connecting, he sends this 1 megabyte buffer back to the client, which of course is a very special benchmark showing exactly what Node's strength is. So in other scenarios, Node will not do as well. But for this particular example, when running the benchmark with 100 concurrent clients and the 1 megabyte response, Node can do about 822 requests a second, whereas Nginx, which is probably one of the fastest HTTP servers out there, will only do 708 responses. Sin and Mongrel, of course, much lower since that's not what they're really good at. And also it is very likely that Nginx is simply doing more work for every request. I think he was actually serving a file, and Nginx was caching the file, otherwise there's no way it would be that fast, but it might have issued a few stat calls along the way to see if the file was updated. So those are very special circumstances. And of course, Nginx peaked at 4 megabytes of memory. Node peaked at about 60. That's not surprising since Node, of course, is using a virtual machine for JavaScript. There's garbage collection going on. There's all kinds of objects being created and probably not collected at all the times. And so that's why the memory usage is much higher. And the speed is also, as I said, due to the very special circumstances. And if you actually want to see Node doing really poorly, try the exact same benchmark, but just use a 1 megabyte string. Node right now is very inefficient in copying huge strings to a socket, because that essentially does a mem copy, and V8, well, I think Ryan is working on a way to make it really fast by going under the hood of V8 and extracting the various representations they store strings in, but at this point that's something Node is not good at. And that's something that might bite you if you have huge JSON responses that you send back. So just worth knowing that Node, of course, is trying to be very fast, but this was a very special benchmark showing that it's very fast at pushing static buffers. Danger, Will Robinson. I also mentioned that I wanted to go a little bit into security, but I probably packed my description of the talk way too densely, so I'll make this one quick. Node makes it trivial to manage thousands of connections on multiple protocol levels. That, of course, doesn't bring any new attacks. It's just all the stuff that you as network administrators are used to, but it gives a powerful tool in the hand of people who can just write some JavaScript. So even small targets might become now easier to attack just because the ways to attack them are much simpler using Node.js. You can spawn 1,000 HTTP connections and just let them hang. And if you have a misconfigured web server, that will kill that thing right away. Yeah, that's the end of the talk. Again, the startup I'm working on is Transloaded. We do file uploading and processing as a service for other web applications. If you want to do some video stuff, you can talk to me about that. And there's the questions right here. I have a bonus slide if we have a minute more, but yeah, we can start questions. I don't think so.
So, thank you very much for your talk.
Hey, I have a question here. So suppose I have written script which uses not only the standard libraries but also this Pcap, which is installed via npm.
Yeah.
So is there an easy way to create a standalone binary that I can deliver onto arbitrary target system and run it without first installing the whole JavaScript stack and additional libraries and stuff like that?
I think there's one library called NVM, which kind of lets you bundle Node as well as a few dependency libraries, including your own application. I don't know how standalone that really is, but Node comes with very few dependencies, so I think what you're trying to do is very doable, if not already solved by somebody out there. Okay.
Okay, one question from the Peace Missions. It was in the beginning of the talk. Are you actually telling me someone has improved JavaScript so it gets closer to modern languages but still have the old well-known C-style memory problems? Isn't that a little unlogical? I see a user abusing JavaScript as a port bouncer.
As a port what?
Port bouncer.
Oh.
It's from the Peace Missions, the question. Test. Okay, it's back. I don't know how that worked. Either way, I'm not sure about this question itself. I think generally the question was, wouldn't JavaScript suffer from the same kind of problems that C would suffer from when doing network programming? Is that maybe a good summary? Okay.
I'll just answer that question.
The port bouncing stuff is irrelevant. Okay, then maybe the next question from the
Okay, well, just to answer that question, yes, of course. The only thing that Node will do for you is to deallocate objects automatically, even those buffers that we talked about. But yeah, if you play with raw memory and you do crazy network stuff and you do buffering, you need to kind of know what you're doing to get good results. It's not a magic unicorn.
That Pcap thing you've demonstrated. I can't really be sure that the packets are coming, are written to the disk in the same order they're coming over the network. Can I? Because every packet spawns a new function and it's non-blocking, and some can take longer to write the stuff and some cannot. Can I rewrite that thing in JavaScript so that I can be sure the packets are stored in the disk in the same order as they're coming on the network?
Whoa, okay. So the library itself, I think, takes care of the ordering. I think a lot of the library itself is written in JavaScript, and it's just using the libpcap bindings. But you'd have to look at the library, and maybe you need to contribute a patch or start your own thing.
The thing I want to say is every packet spawns a new function call, and I can just wait indefinitely in some random function call, and then it will never get written in the same order. You see, it's it has implicit threading through the non-blocking I/O, but I can't control that threading. I can't say, okay, this is packet number so-and-so, and we wait for that
you
packet
can't
to be
wait.
written.
If that's what you mean. You mean wait for another packet?
No, I wait with the next packet until the previous packet is written, which I could do in C or something.
Yeah, no, you can't do that in Node because everything is non-blocking. You don't get set up.
Okay, question answered.
Okay, then a second question from the Peace Missions. Are there any noteworthy applications out there using Node.js?
I keep turning it on and off, and then it works for a minute again. I don't know why. But yes, Yahoo is using it, Joint is using it, GitHub is using it. I think Yahoo Mail is a specific application.
With the server running on Node.js, is it more resistant against DDoS attacks, or is this something? Is this irrelevant?
It depends on the attack. Just the fact that it's non-blocking and by default gets a lot more requests per second and just spawning, I don't know, 20 CGI processes of your favorite scripting language, that should make it more resistant against handling many concurrent clients. But essentially, at a bigger scale, it will end up suffering the same problems. If you have attacks, you need to look at the specific attack and come up with a specific solution. Node has no built-in DDoS prevention or anything. Okay.
So this is already the end of the talk. We're already over time. Thank you very much for your talk. Give him a warm half applause, please.